All right, welcome back to pre-calculus. We are going to be using de Moivre's theorem to figure out the indicated power. Okay, so it's going to give you something like this: 4 times cosine pi over 30. This is radians, okay, because there's no degree symbol, plus I sine pi over 30. There's also pi's in it, which generally tells you that it's going to be in radians, but that's not 100%. All raised to the fifth power. Okay, simplify. Okay, so that's easier said than done, but there we go. We'll figure this out. So the easy part, right? We have 4 times, we have cosine of pi over 30 plus I sine pi over 30 raised to the fifth power. Okay, so that's going to be 4 raised to the fifth power. Okay, and then we're going to have cosine of 5 pi over 30 plus I sine of 5 times pi over 30, 5 pi over 30. Now, if I didn't know any better, I'd say, you know what? I'll bet that reduces 5 over 30. I'll bet that's cosine of pi over 6 plus I sine of pi over 6. Okay, that's what that reduces to. Okay, all we did was say, okay, well, remember that what de Moivre's theorem is. You guys get this as a formula. It's z, it's the modulus of z raised to the power. And then times, we have cosine of n theta plus I sine theta. Okay, like I said, I always think this is kind of a cool formula, but and again, count the number of times I've really had to use this during my undergraduate career on pretty much one hand. It comes up every once in a while, but for the most part, it's not something that I needed to have at the ready to do every problem or to do any particular set of problems. Okay, so here we go. Now, this is 4 to the fifth power. 4 is 2 squared raised to the fifth power. We have a power raised to a power. That's going to be 2 to the 10th times all of this. And 2 to the 10th, that is 1024. That's a K. Back in the day when computers were just coming, just being made, we'd have 1,000 kilobyte drives. Okay, so yeah, it's 1 KB, and 1,000 kilobytes was 1,000 bytes. That was 2 to the 10th power. I thought, hey, if you learn all of your powers of 2, you'll be really good at computers. So I don't know how much that's helped you, but there it is. Cosine, what is cosine of pi over 6? Cosine looks something like this. So pi over 6, that's a pretty small angle, so we're going to have this as square root of 3 over 2 plus I sine. What's sine look like? Sine looks something like this. So at a small angle here, pi over 6, that's like 30 degrees. We're going to be here. That's just going to be 1/2. Okay. And then we'll be able to do that. So half of 1024, that's 512. So we have 512 root 3 plus I, actually, we're just going to say 512I. Okay, and that's going to be our answer for that. So let's see here. 512. There we go. 512 times the square root of 3. Oops, not plus, just square root of 3. That's all we need. All right, plus I sine. And actually, you don't need that. Sorry. You just need 512I. All right, and that is what this value is going to be. Okay, I think we're good. We got our green flag. We are ready to move on with our lives. So that's a pretty standard problem. I would lose a little sleep giving this to you guys on a quiz because I would think it was too easy. All right, but yeah, just as a note that you would be getting this formula. So if you have to say, "Oh, I need to look up de Moivre's theorem," like you're in the right. Okay, that is the correct thing for you to do. Like I said, I've used this about a handful of times since when I've learned it. I've always had the opportunity to look it up, or I've been well warned that this kind of a problem would appear in a quiz or an exam or something like that. Like, hey, you're going to need to remember this. So that's a fair thing to do. So if you have to look this up, that's fine. Someday, if you have to memorize it, that's fine too. But it's not something that's going to pop up where it's like, hey, you should know this. No, it's like, hey, you should remind us of this. Okay. So I would write down this formula the way it is in your book. I'll just copy and paste it from the book onto your quiz. So you don't have to be memorizing this formula. Don't do that. Okay. You know how to use it, but you don't have to memorize it. Okay. So let's go ahead. Do we want to try one more? Do we want to try number 10? 9 and 10. So this guy here, this is Demoff's theorem. This is find the value find simplify this thing. Okay, and here, as much fun as I think it would be for us to FOIL all of this out. Okay, so this is 3 root 3 minus 3i raised to the 5th power. Okay, so we'd have to multiply this out. We'd have to write this down 5 times and then FOIL each pair out. I don't think we really ought to have that much fun in our lives. Okay, so what we're going to do is we're going to convert this, or first step, convert to polar. Okay, and then once we have this thing in polar, we're going to apply Demoff's theorem. Okay, so that's how we're going to do that. So how do I check this thing out? Excuse me, how do I check this thing out in polar? Convert this thing to polar. So we want 3 root 3. This will be 3 root 3. This will be, how about minus 1 root 3? 1 times root 3. That'll be down here. Okay, so here's a triangle. All right. So let's go ahead and figure out the modulus. Okay, so we're going to say, okay, well, the modulus of z here, the absolute value of z, is going to be the square root of 3 root 3 squared plus negative 3 squared. Right? So that's not too bad. So what is that going to be? That's going to be 3 squared. That's 81 times 3 plus 81. 3 squared. I'm sorry. It's not 81. It's 3 squared. That's 9. Where am I going with this? Oops. Okay, let's go back. Change that back to a 80. Change that back to a 9. So it's going to be 9 times 3 plus 3 square rooting. Can I go ahead and factor that out? Okay, that's going to be change that to a 9. So we're going to have square root of 9. And then we have 3 plus 1. That's a tough one. So this is going to be 3 times the square root of 3 plus 1 is 4. So this is going to be 3 times 2 is equal to 6. Okay. So all we're doing is just doing Pythagorean's theorem on these values here. Okay. So my modulus z is equal to 6. Right. Now this is why we draw a triangle, because we know that theta, right, this angle here, is equal to the opposite over the adjacent. So that's going to be negative root 3, right? That's my opposite side. And then my adjacent side is going to be 3 root 3. Okay, so the tangent of theta, okay, the tangent of theta is equal to negative 1 over square root of 3. Okay, that means that tangent is equal to, we have negative, that's going to be in the 4th quadrant there. Hey, what do we know? It happens to be in the 4th quadrant anyway. Okay, so inverse tangent is going to give us a 4th quadrant number. So we're going to end up with, I think 1 over root 3, that should be negative pi over 6, I believe. Okay, or negative 30 degrees. Demoff's theorem doesn't really care if you've expressed angles in degrees or in radians. Okay, it's going to work the same way either way. So don't worry too much about that. Pick one that you'd like to go with and go with that. Okay, so I have the modulus, 6. Okay, and then we have the theta, negative pi over 6. So all we're going to do is say, okay, well, this is 6 times cosine of negative pi over 6 plus I sine of negative pi over 6. And we're all going to raise this to the 5th power. Okay, so we're going to have 6 raised to the 5th power. I'm not going to be able to do that one in my head because I don't know 3 to the 5th. Okay, and then we have cosine of negative pi over 6, negative 5 pi over 6. We have cosine. This is going to be cosine negative 5 pi over 6 plus I sine of negative 5 pi over 6 because we multiply the exponent through. Where is negative 5 pi over 6? It's right here. Okay, so it's in the 3rd quadrant. So sine and cosine are both negative here. That's fine. Okay, so we're going to say, okay, well, cosine of negative 5 pi over 6, that's going to be square root of 3 over 2. That'll be a negative number here, so we'll put the negative in. Okay, minus, and then sine of negative 5 pi over 2. That's again here, that's the 3rd quadrant. So we're going to go ahead and say, oh, that's negative 1/2. Right? So the last thing I'll do, or the last thing, the penultimate thing that I'll do here is I'll say, well, what the heck is 6 to the 5th? Because I don't know. 6 raised to the 5th power was my next guess. 7776. And then we'll say divided by 2, because that's one of those things we have to deal with. Okay, so I have 3888 square root of 3 minus 3888I. And that's going to be my answer for this. Let's check and see if we got this right. Okay, so we have negative 3888 root 3. Okay, and then minus 3888 I. All right. Oops, what do I have a square root in there? Oh, that's because I just put it at, never mind. Minus 3888 I. This one still needs a root 3 though, so we're double checking this guy here. Root 3, and then we'll move out of the parenthesis or move out of the thing there, so we can go ahead and do that. So let's go ahead and check. Hooray, we got our green check mark and we are ready to go. So that would conclude 7.3. Again, I will write down the Moss theorem on your exam. Don't worry about trying to memorize that. Just know how to use it, know when it applies, and you'll be fine. Okay? Because don't multiply all of this out. Because one of the rules that we have for giving the problems is your guys are going to ask me, like, how do I do this? And I'm going to have to demonstrate it. And if you think I'm going to foil this out, you have got another thing coming. I don't know what that is, but it is not me. Okay, so I'm going to use the Moss theorem to multiply this out. Okay, so take care. Good luck with that, and practice it again. If it comes out of the pencil, then you're going to know it better. If you just watch me do it out of the pen, you're not going to do well when you have to perform it yourself. So please practice this. Try to get it to come out of your pencil. Right? And I'll see you in the next video. That'll be 7.4. See you then.